Hello everyone, can you hear me? Oh, you can hear me. Say hello. Didn't hear. Okay, I will use this one. Okay, my name is Alexey Ivanov. I'm from Russia and I will tell you about webpack today. Webpack is a de facto standard for front-end development in Russia. We use this pretty much every big project. If you're making a front-end application and it should have a lot of logic, well, you use webpack. If you're doing a big site, you use webpack. There is pretty much something happens. Sorry. Okay. So yes, I want to talk about webpack. And something happens in background. Yes, it's some kind of magic. Okay, I think we will record something this way. Okay, next. But before I start, let me talk a little about myself. I'm working in the company called lvanov. We have a very cool logo. It's one of the main reasons why I work here. And it's not the only cool thing about us. We're also doing a lot of open source, and I think you will probably know things like after prefixers and post-CSS. It was created by my colleague Alexey, Andrei Sitnik. He is here with us today, and he will have a talk later. We also have a lot of other open source. Maybe you use some of it, maybe not. But then we are not doing open source, we are working on a lot of big projects for companies like eBay or Get. And I'm working on a project called eBay for Business. It's a service that allows big companies like big sellers to publish a lot of items on the eBays in different countries at the same time. And eBay have a lot of different requirements for bundle size and of the loading speed. And to make sure that I meet these requirements, we are using a lot of debugging tools and profiling. And when you're using them, they can see a lot of strange things inside our bundles. This is a webpack bundle analyzer. It's a program that can be used to analyze webpack bundle and see what comes inside of it. So you can see that there is different libraries, there is node models, there is Bluebird, there is MobX. And you can see how much they did and how they are distributed between the different chunks. And when you start looking at these things, you can see a lot of strange things that going on here. You can see that some libraries like Odash or underscore are repeated in the different versions, and you can multiple copies of them inside your bundle. Or you can see that some libraries like Moment.js can load hundreds of local files with different translations for different languages, and you are only using it for one or two languages. Or you can see that there is some strange polyfills that you did not add yourself, but for some reasons are there inside the bundle. And there is some libraries like React.js that you add, but for some reasons they weight more than you add them, not from NPM, but by hand in the compiled states. And there is tree shaking that did not work for some reasons, and you was promised that it will work in Webpack too. And then there is chunks that you add, but for some reasons there is copies of React in each chunk, and you load a lot more code than before you start using chunks, etc., etc. And you can see that something happens. It's not terrible things. They will not break your bundle, but because of them, your bundle will wait more, will load slower, will have a slower startup time, and will be harder to debug. So if you want to do something about it, you should understand how it works. And I'm pretty sure that if you came after this conference to your company and try to run something like a pack bundle analyzer on your bundle, you will see that you probably have these problems too. So let's talk about why these problems happen and what you can do to fix them. Okay, so how can we talk about it? To understand why these problems happen, we should understand how the pack bundle works. And to understand it, we should start with basics. We will start with CommonJS, and we will talk what is it and why is it important and why we should emulate it inside the browser. Then we talk about basic bundle structure and how it works. Then we will talk about some plugins, like define plugin that will help us remove or add some things inside our bundle. And then we talk about how the JavaScript minification works and why webpack do some things that will help you later when you try to minify your bundle. So this is things that we talk about. Also, we will talk about chunks a little, and we will talk about the new things in Webpack 2 and 3. It's tree shaking, it's yes models, and more modern things like scope hosting. So, okay, let's start. CommonJS. I'm sure that you all know what is it and how it's used. It's the default model system inside Node.js. So then you write something like require on exports its CommonJS. And why should we talk about it? Node.js was created a lot before Webpack was created, and there is hundreds and thousands libraries inside of NPM that can be useful in browser too. So then Webpack was created. It was created with the goal to emulate how Node.js works too. So what we need to emulate to make Node.js models work in browser? We have files, and we have some additional variables that was available in Node.js that was not available inside our code. For example, we have these things. By default, files in Node.js have scope. It have scope. It have global variable called exports, and it was by default equals to plain object. And there is model exports that pretty much the same thing. And then you write this inside your model inside the Node.js. It also equals exports. So why is it important? It's a thing that you should emulate, and as you can see, it refers to the same things, and if you replace model export with something else, it will break in the file that you try to import it to. Also, we have require. It's also variable that available in Node files and not available browser. So we need all these things to make our files work. So how can we emulate it? The simplest way to emulate all these things inside the browser is to add some global variables. We also need to make sure that file scope is not visible from the other part of the application. So to do it, we will wrap our file content, we will read it to a single file, and we wrap it inside the function. And we will add our variables as these function arguments. It's pretty much how Webpack works. So basically we have a file, we read it, we add it to one big file, then we wrap our file inside the function and we send this thing inside. As you can see, we did not send require here. Instead, we use Webpack require. I will say why we do it a little later. But the second thing that I need you to pay attention to is this 0 here. As you can see before, we have a path, but inside browser we did not have path because there is no file system here. So we can use something shorter and something more unique. In this case, we are using array with indexes. All these files will be added to one big array, and when we want to refer to one file from another, we use indexes of this array. So this is the simple Webpack bundle. It's not much code. I urge you, then you written from the conference, try to create a simple Webpack bundle with just single file. It will be something like 30 or 40 line of codes, and half of them will be comments. But important things from here is the following. We have these functions inside our browser. It's a median invocable function. And we send our models array inside of it. And we execute it. Then it is executed, it will run the function called webpack require with this index. This index is basically the index of the root element of the pack bundle. Then you create bundle, you say from which file it should be started, and this is this file. So we just executed the root file here. And what happened next? So basically, there is few things that we should also add to make our files work in browser. First of them, we should only execute each file once. It will help us with memory and help us do some other fun things. For example, then you run code inside your Node.js, and as I said before, we should emulate Node.js. There is things like global visibility. And if you write a file like this, you have a variable inside of it, and you have a counter, and you have some methods that decrement or increment this counter. Then it will be shared between all files that require this file. So basically, if you require a counter in one file and increment it here, then you run it in the other file, it should also be incremented here. So because of it, we can't execute our functions each time we run it. We have to execute it just once and then save its results in some place. So this place is installed models. So what will happen when we run webpack require? Webpack require function will try to look inside our cache, inside installed models, and look for initialized model. If it was not able to find it, it will create this placeholder. It's just plain object, there is a couple of cases, and only important for us is exports. As I said before, it's by default equals to blank object. Okay, we created this placeholder, and now we have to execute our function. As I said before, in Node.js, inside the file, there is local scope, and this is equal to the export, so we may have to emulate it. So how can we emulate it? We run models from our array with model ID, and we call it with this equals to model exports. This way we will have all the things needed to emulate Node.js file system in place, and as a result, exports will have links to all our public methods. Okay, so we emulated it, and we now just have to return model exports from it. Okay, one more time. We have models array, we send them as an argument to this function, and it will become the models here. Then we run webpack require with index, it's the root index. Then we run function webpack require. Then when we run this function, it will look for model ID inside installed models. If it was not able to find them, it will create them from models. And this way it will work. So it's the simple possible bundle. It works very simple. It's very hard to break it, but we will try it anyway. So how can we break it? And how can we do something strange with it? There is multiple ways to do it. One of them is to remember that we still have to emulate Node.js, and in Node.js there is the thing called model resolving system. Then you run not a link to file inside the require, but you write here path to model. There is a model resolving system that starts to work, and how it works. First of all, it will look for a model, not the models folder inside your current folder, and if it found it, it will try to look for model name folder inside of it. It will, if it was possible to find it, it will look inside of it and try to load it. But if it was not able to find it, it will go to the parent folder and look for model models here, and then to parent folder, and it will repeat it till it returns to the root. Then it will throw error if it was not possible to find it. But why is it important for us? As you can see, then you install some model inside NPM. It can have its own dependencies. For example, you have a library Ladash you're using in your application, then you have some other library. And this library uses other dependencies, and one of them is Ladash too, but different version of Ladash. So the way NPM works, it will create its own node models folder inside your lib and add its own copy of Ladash here. This way it will have different models of Ladash in your file systems. And it's not a big problem when you're using it in Node because you don't have file size constraint here. But if you're making a bundle, then you will have both versions of Ladash inside of your bundle. And I think it's not the thing that you want. So how can we fix it? Well, there is multiple ways to fix it. If you're sure that your different Ladash versions use the same API, then you can just use aliases inside webpack, you can write the global path to your dash folder, and then it will be always used while webpack will try to resolve its ways. This way, we will always have the same version of dash. We can do the same things for underscore and even replace underscore with dash if you want to. Okay, it's a simple bundle, but Node.js and webpack can do more difficult things. One of them is resolving require paths by the mask. And how will it work? Well, basically, when you're using Node.js, you can use anything you want inside the require.js path, because, well, you did not have to take all the files with you. You can just resolve this file name and just load it at the execution time. But we can do it in browser by obvious reason. We can't take all files with us. So we need some way to emulate it too. How can we do it? So first of all, we can't use any expressions here. We need to have one part of the file name in place, because there is only way how webpack can understand which folder or which part of path it should look at, and it will limit the scope of the files that will be loaded. So, okay, we use this part, we create regular expression from it, and now we try to match this regular expression to our file system. And then we will add all files inside our bundle. And then we create one more file inside our bundle with the map of all possible file names. So basically our expression match these file names inside our file system model, model.js, model2, etc. So we have to add all these files inside our bundle. And then we will create something like this. We will compile this line to this line. As you can see, it's new model. It's not one of these models. It's other index. And we will send it as argument here. And it will be resolved inside of it. This way we can load a lot of files at the same time. But here comes the other problem. All models are inside bundle. Resolving model is here. And some libraries that are created for Node.js and not created for browser can load a lot of models. For example, if you use moment.js, then there is this line inside of moment.js file. As you can see, it loads all locales at the compile time. And there is a lot of locales. There is more than 100 locales here. So basically, if we just run this code without some tweaks, we will have a very large bundle, and most of it will be not used. So how can we fix it? There is a webpack context replacement plugin, and we can use it to replace the expression that we will have from here with some other expression. For example, if we want only use English and Chinese locale, we can write something like that, and only these two locales will be loaded. Okay. This is about paths, that's it about basics. Let's talk about define plugin. What is define plugin? Well, there is situations inside your bundle then you want to add some variables with some data that you did not want to hardcode, like version name or different flags for production or development environment. How can you do it? Well, there is a define plugin in webpack that doing it, and it looks like that. You write your variable names, you just write normal JavaScript files, and then you configure it. Well, it's a simple config, actually. You just write what you want to replace and what you want to replace it with. But all examples of webpack defined plugins shows that you should use JSON-stringify about it. Why is it so? Well, basically, we want to insert the string inside our code. And if you want to insert it as string, we need to have quotes around it. And to not lose this quote, we need to double quote it. And the JSON-stringify plugin will do exactly that. You can do it by hands, but if you have some big structure like object or function, it will be not very easy to do. So JSON-stringify will simplify things for you. Okay, so what will happen when we will replace it? Something like that. We have a version and process env, and after replacement we will have a string here, but we will have a Boolean value here. Once again, we have two variable and string here, but only Boolean here. Why is it here? This way, if we do it, Uglified.js and other plugins that will remove code from our bundles will be able to understand that this code is not needed. So if there is something else not variable, they will not be able to do it. Also, look at this place. There should be webpack require in normal bundle, but we still have require here. It means that webpack did not replace it. It left it at least, and it will not add this model inside your model array. So if it was false, it will not be resolved, but it will be resolved. This way we can remove some files from our production bundles. Something happens. Sorry about it. So okay, we replaced it, and now what we talk about next? Next problem. If you replace it not with exact string, but some part of string, or use variables inside your expressions, then webpack will not be able to understand that this code will enable be executed. So it will not replace it with true or false, it will replace it with variable name. But we want this code to be named add to out bundle. But if it's not true or false, it will be add. As you can see, require was replaced and this file was added to undo bundle. Okay, in example before, I showed you process env node.env. It's a standard name for a variable used inside Node applications and some JS application to distinguish between production and development version of app. And process env is standard name for this variable. So a lot of libraries use it. So if you have inside your bundle React, Redux, or something like that, it will be here. But what will happen if you are not using defined plugin and didn't replace it? The following thing will happen. As I said before, we need to emulate Node.js. So if there is something that works in Node.js, we need to polyfill it. So how it works? Process is standard variable inside the node. It can be used in Node application. So we cannot be sure that it's just our flag to production or development version. So to make sure that Node code works inside browser, webpack will try to polyfill things like that. So it will add 300 lines of the polyfills to emulate process inside our browser, and I think it's not something that we want. So if you want your bundles to be small and work fast, you should always use defined plugins and always replace process env node.env. Okay, so again, we write some plugins, we created bundle, we use defined plugin to mark some parts of code as safe to remove, but how we can remove it? Well, to remove it, we can use Uglified.js plugin or some other plugin that can minimize JS. And how does they work? This is an example of Uglified.js code before Uglified.js. As you can see, there is a function and some variable side of it. But because the functions have scopes and we can know that these arguments can be used outside of this scope, we can safely remove them and rename them to the shorter name. So we can replace variables with the short name and remove unused variables. Okay, but this will work only if we are sure that these variables are not accessible from the outside world. If we have this code in the root scope, it will not be removed. We have to leave the variable names as is, and we can't remove variables because they can be used from other files. Okay, but back to our if expressions. As I said before, we have true and false, and if you show this code to Uglified.js, it can remove all the unused code. So if something true, we always execute it, and if something false, we always remove it. But it also works only with the booleans or strings. If we have something like the variable inside of it, it will not work. This code will not be removed. It will be shorter, but it will be still here. This way, if we have something like this, like from previous example, this code block will not be removed, and this line will still be in our bundle. It will be never executed, but it will still be here. Something happens again. Okay, there should be a large section about chunks, but unfortunately I don't have enough time for it. So I have the full version of my slides, and if you want to understand how chunks works, then you should download them. There is 20 additional slides with the examples about chunks, problems about chunks, and info about how it works. I will show this at the end presentation too, but if you want to understand how chunk works, ask me after the presentation or, well, try to read it yourself. Okay, but more interesting things. We talked about how bundles works and how basic things inside them works. But all these things was inside the first version of Webpack and didn't change from that time. But inside the second version of Webpack and inside the third version of Webpack, there is a lot of additional code and a lot of additional logic that can help make our bundles weight less and work more efficient. Let's talk about it. The first thing that I want to talk about is ES models. So it's pretty much the same thing as common JS models, but have a slightly different syntax. Import instead of require export instead of exports, model exports replaced with default. But it's not important. Important thing is this. Imports and exports are now always immutable. You have to always write the full name here. You can't have expressions here. You can't generate them on the fly. And why is it important? Let me show you this slide. It's a tweet from Jay Dalton, creator of the Odash, and it's a table of comparison how much code we can remove from Odash loaded inside our bundle with different flags enabled in the Webpack by default. There is 3 lines that are important for us. It's tree shaking, scope hosting, and pure model. As you can see, if we just import Odash inside of Webpack with this line, you will have this bundle size. It's more than 200 kilobytes. But if we enable all flags, it will be just 3 kilobytes or 70 times more smaller. But how can we do it work? Well, first thing is immutability. As I said before, because we have ES models and their names are always static, we can analyze them and use something called reshaping. So it works like that. We have some exports and have some imports. And we are sure that this name will never change. So then we are creating our bundle. We can read this name from exports and read this name from imports and try to match them and see if all exports are actually imported. So if we are only using import 1 and did not use import 2, we can safely remove export 2 and import 2 too. But it's not so easy in practice. In practice, we have side effects. For example, if we have code like this, export of some methods, and it was a result of function evaluation, this function can have global side effects. For example, it can add something to a global variable window. And this way, if we just remove it, our bundle can break something. So we can just remove it. So how can we safely remove it? To safely remove it, we will do the following. First of all, how it compiles to JS code. Let's start with the imports. They are pretty much the same thing as in common JS example. We have function Webpack require again, but this time we generate some automatic name. Don't worry about its size, it will be removed by qualify.js and replaced with something more short. And it's pretty much it. But the fun thing is in the other file that have exports. So basically we have exports between each variable before, but now we do not have exports here, it's just const. But the const that we are sure that will be imported have this function here. It's a function that will import it to another files, but const2, the one we know will not be imported, did not have this path. This name we will know that it will be not imported. It can be still evaluated, it will add things to the global scope if it needs to, but it will not be imported or exported. This way we can run uglify.js on this file and remove safe things and leave only unsafe things here. But the problem is that because we have to work with the ES6 models specification, we have to evaluate each file on load. So basically, if we have some files in the dependencies and imported something inside this file, we should always add this file inside our bundle and evaluate it. And if it has some other dependencies, we should always add them and evaluate them too. It's the only way to be specification compliant. But this way, we will have a very large bundle still. It will be smaller when we are not using anything, but still large. So for example, we have 220 kilobytes before, but now we have 140. That's still pretty much. It's not a lot smaller. It's better, but not good. And here comes the next thing that we will talk about. It's called scope hosting. It was set in Webpack 3, and it works like that. For example, let's look again about two files. We have a simple file with export. It have exported const with some number, and we import it in another file, and we will just try to log it to console. Before we use scope hosting, our bundle will look like that. We have an array, we have a function inside of it with the first model, function inside of it with the second model. But now that we enable scope hosting with using the model concatenation plugin, you have this following code. It will create one function and it will place all our models inside of it. And if we have some conflicting names, it will rename it. This way, because all our files are inside one scope and things like Uglify can see them and they can safely remove them, our bundle will be even smaller. As you can see, we now have only 90 kilobytes. It's still a lot, but it's better than before. And here comes the next thing. The next thing is called the pure model. It's experimental function. It was not a part of the bundle. Webpack by default, it's still in the separate branch, and to use it, you have to clone Webpack from the Git and build it yourself. But if you use it, we can do some fun things. One of them, as I said before, we should load and evaluate all ES models files because we did not know if they have side effects. But what if we know? And pure models is a way for library creators to Webpack about if the libraries have side effects. So if they add this flag inside the package.json, then it's something like, I don't have side effects and my dependencies don't have side effects promise. So if Webpack finds this file inside package.json, it will do the following things. By default, example again. We have some library, it has a lot of re-exports from other files, and we use only one function inside our application. So before we use pure models, we will have all these models inside our bundle. But now, because we know that our pure models flag is set to true, that all these models did not have side effects. So Webpack can safely remove anything that we did not need, even the index file that was used to import them. So instead of 4 files, in this example, we will have only 1, and it will help us very much. As you can see, this way we can remove everything to just 4 kilobytes. But it's a case then we only use pure models and tree shaking. But if we use pure models plus scope hosting and tree shaking together, we can have even smaller library. And this way, promise about tree shaking will finally be fulfilled. Okay, we know how bundle works now. We know what flags we have. We know what problems we can have. But how can we find if we have these problems or not? I will tell you about two libraries that can help you with it. First of them is called webpack Punto Analyzer. It's the library I was showing you in the first slides. It shows you the bundle structure, it shows what files came inside your bundle, which libraries you have, and what you have in each of your chunks. But it will not show you why this file was added and what files have links to it. And to see it, you need the second library. Webpack Runtime Analyzer will help you understand why this library was added to a bundle, why this file was referenced, and things like that. So you can understand what happens inside the bundle better. So, what's the final point of my talk? The Webpack bundle is not very hard. You can understand how it works pretty simply. Just create a simple bundle and look inside of it. It's just 40 lines of code and half of them is comments. Don't be afraid to look inside of it when something is broken. It's quite easy to understand why it was added or was removed and how it works. If you want some reference, you can use my slides for it. Then you add new library, always run Webpack Bundle Analyzer or something like that, because it can add some strange dependencies or can change your bundle in some strange way, and you want to know about it before you ship your code to production. Also, when you create some chunks, if you want to understand that there is no strange thing inside your chunks, you have also run some bundle analyzer tools and look for it. Okay, and don't be afraid to look of it inside of it and experiment. Okay, it's all. If you have questions about the Webpack, you can ask it now.